You may hope mysterious radio signals emanating from planets outside our solar system are evidence of ET attempting to phone home. But instead, they can be explained by ferocious lightning storms millions of times more powerful than those on Earth. Astronomers have analyzed an unexplained radio signal from a mini-Neptune to conclude it could have been created by 53 lightning flashes on the exoplanet's surface. The planet in question, HAT P11b, was observed by French astronomers in 2009, who recorded what was thought to be a weak radio signal coming from it. This planet is about 5 times bigger in size than the Earth and 26 times more massive. The following year they tried to locate the signal again, but were unsuccessful, leaving the phenomenon unexplained. While conspiracy theorists may claim it could have been created by intelligent aliens traveling across space, researchers from the University of St. Andrews School of Physics and Astronomy came to a very different conclusion. We assumed the signal was real and was coming from the planet, Gabriela Hodozin, the Life, Electricity, Atmosphere, Planets, LEAP, Project PhD student leading the study explained. Then we asked the question, could such a radio signal be produced by lightning in the planet's atmosphere, and if yes, how many lightning flashes would be needed for it? They made an assumption that the physics of lightning is the same for all solar system planets and found that 53 lightning flashes of Saturnian lightning strength would explain the baffling signals on HAT P11b. Such lightning bursts would be unlike anything we see on Earth. Dr. Paul Rimmer, LEAP researcher and co-author of the paper, said, "Imagine the biggest lightning storm you've ever been caught in. Now imagine that this storm is happening everywhere over the surface of the planet. A storm like that would produce a radio signal approaching 1% the strength of the signal that was observed in 2009 on the exoplanet HAT P11b. This means the planet must have ferocious weather." Ms. Hodozin continued, "Such enormous thunderstorms are not unreasonable. Studies conducted by our group have also shown that exoplanets orbiting really close to their host star have very dynamic atmospheres, meaning that they change continuously, producing clouds of different sizes, even whole cloud systems, all over the planet's surface. HAT P11b, being so close to the star, is likely to have such a dynamic, cloudy atmosphere, which would allow the formations of huge thunderclouds, focusing the lightning activity to a certain regime of the planetary surface, such as the face of the planet, which was observed in 2009. The team hoped this intensity of lightning could be observed with optical telescopes. But its efforts were thwarted by the powerful light emissions from the star around which HAT P11b orbits. The process of lightning discharges involves plasma being produced at very high temperatures and the release of a large amount of energy. This results in chemical reactions in the atmosphere that otherwise would not occur. These reactions produce molecules that can be used as lighting tracers. The team considered whether such enormous thunderstorm clouds produce these tracer molecules, which could then be observed by Earth's telescopes. If so, hydrogen cyanide could serve as a potential fingerprint to prove the existence of lightning. And this molecule could be observable in the infrared spectral band even years after the huge storm on HAT P11b would have occurred. Ms. Hodozin said, "In the future, combined radio and infrared observations may lead to the first detection of lightning on an extrasolar planet." The importance of the study is not just this prediction, but it shows an original scenario for the explanation of radio emission observable on extrasolar planets. Dr. Christian Helling, the LEAP project principal investigator, said, "With all necessary caution, linking extraterrestrial lightning and radio emissions will open a new window to prove the presence of atmospheres and of clouds on extrasolar planets, both being essential for the existence of life as we know it."